In this lesson, we're starting to explore a few transformations. And a transformation is basically something that changes where a figure is, or the shape or size of a figure, or its orientation. And the input is the x comma y original point, and the output is what you get after you do the transformation. And and you'll see the vocabulary that we refer to the original as the pre-image and the output as the image. And familiarize yourself with the notation. We denote the pre-image items with just a letter, whereas we denote the image information with primes. So you'll notice here this is point A, and then this transformation happened to it and it became a prime. So just understand what you're looking at and what I'm referring to when I say prime. And a lot of the transformations that we're going to be doing will happen using coordinate notation. And so let's take a look at doing a transformation using that coordinate notation. In this transformation, we see that x comma y will be transformed to x minus 4 comma y minus 3. And so they have this nice, neat table set up for us where we have our pre-image points, the x comma y. We have the rule that is describing what is happening to each x comma y. And then we have a column for where our image excuse me, will land. So the first one was done for us at 0 comma 4, and then they did the 0 minus 4 for the x rule, and then the 4 minus 3 for the y rule, and found that a prime lands at negative 4 comma 1. We do the same kind of math for points B and C. So B prime will therefore be located at negative 1 comma negative 3. C prime will be located at negative 4 comma negative 3. The instructions also ask us to go ahead and draw that new image, so we'll do that. A prime was at negative 4 comma 1. B prime at negative 1, negative 3. Yes. And C prime at negative 4, negative 3. And we're filling in a few blanks. The transformation is a translation, meaning they just took the triangle and moved it, and they moved it 4 units to the left and 3 units down. And a comparison of the image to its pre-image shows that they're the same size and shape. Different transformation this time. My pre-image is always x comma y. This time my rule is negative x comma y. And so they've plugged the values into the rule, and we are to figure out what the output is. So R prime is at 4 comma 3. S prime at 1 comma 3. And T prime at 4 comma 1. And let's graph that as well. R prime located at 4 comma 3. S prime at 1 comma 3. And T prime at 4 comma 1. This transformation was a reflection over, and we're supposed to decide which axis. Well, remember your algebra and notice that the coordinate grid here has the x-axis indicated and the y-axis indicated. It reflected over the y-axis. And again, a comparison of the image to its pre-image shows that they are, again, the same size and shape. But it is important to notice, if I look at the triangle on the left and I name its vertices in a clockwise order, it's RST. Now, if I name the vertices of the triangle on the right, it's image. Also clockwise, it's not RST anymore, it's RTS. So it's important to note that yes, they are the same size and shape, but the order of the vertices has changed. And that's something we'll talk about with a little bit more specificity later on, but it's valuable to notice it now. Another transformation, again, notice the coordinate notation. Notice that the rule wants us to take the x and multiply it by 2, but to keep the y the same. Notice this time we've done this a couple of times, so every time we do it, there's more and more blanks to fill in so that we're more and more on our own in our text. So J, notice, is located at -1, 2. K at 2, 2, and L at 2, -4. And in the setup that they have for us for the rule, what they've filled in for us is what we're doing to the x, y. Notice all we're doing is multiplying 2 times the x coordinates. So let's take both the x and y coordinates and fill those in. So that'll become, I'm just copying these numbers over. And then finally, in order to figure out the coordinates of the image, that's where I'm doing some actual math in order to find where my 3 answer points are. So J prime is at -2, 2, K prime at 4, 2, L prime at 4, -4. This transformation is and it's asking us what kind of a stretch by a factor of, and it's asking us what number. So what I'd hope that you'd notice is that vertically, meaning up and down, this triangle didn't get any bigger or smaller. So it's not a vertical stretch, it is a horizontal stretch, and it is a horizontal stretch by a factor of 2. And this is vocabulary that's going to continue to be important to you as you move on to Algebra 2 and further math courses. This concept of a horizontal stretch and vertical stretch. This geometry that we're learning here is going to apply to stuff that you're going to do later on. So a comparison of the image to its pre-image shows that they are not the same size and shape. but they are still both right triangles. So now we're bringing in a little bit more vocabulary. What is a rigid motion? If you recall, in the first two transformations that we did a translation. We took the triangle and we moved it. In the second one, we did a reflection. We flipped it over the y-axis. And when we did, the size and shape stayed the same. And so that's why we would call those kinds of transformations rigid motions. Another term that we use in conjunction with that is to call it an isometry. So as you see in your text, translations, reflections, and rotations are rigid motions. That third transformation that we did, however, is a dilation. We'll talk more about that later on. It was a horizontal stretch, and it did not preserve length and angle measure. Some properties of rigid motions, you can read those. Preserving distance means that segments stay the same length. Preserving angle measure means angles stay the same measure. Preserving betweenness means if a figure is between some things before the transformation, it'll be between them after the transformation. Same thing with collinearity, things being on the same line. Parallelism means that if I have segments that are parallel in the pre-image, they will still be parallel in the image. And then if you read through that last paragraph, you see how rotations and translations preserve orientation, but reflections do not preserve orientation. So you'll recall that I mentioned in the second example that the order of the vertices was different. That's what I was referring to here, that reflections don't preserve orientation. That's very valuable to you as you later on look at transformations and try to decide what kind of transformation occurred. For example, here, we are being asked to look at a transformation and identify what kind of transformation took place. So it's asking to look for a pattern in the coordinates. And again, they start us off a little bit simple. You'll notice that the example on your screen is example B. There's an example A in your text. If you feel that it's necessary, pause the video so that you can look over the part A of example 1 before we do part B together. So we're looking for a pattern in the coordinates. It says the coordinate of each image point, what? The coordinate of its pre-image. So let's look at those x-coordinates. And what I would hope that you'd notice is that the x-coordinate stays the same. So to fill in that blank, the x-coordinate of each image point is the same as or equals the x-coordinate of its pre-image. Now let's look at the y-coordinates. What I'd hope that you'd notice is that they are opposites. So the y-coordinate of each image point is the opposite sign of the y-coordinate of its pre-image. The transformation is and we have to determine whether it's a translation, rotation, reflection, or some kind of a stretch. And if you haven't already noticed, let me draw your attention to it. If I look at the pre-image, which is this figure, and I name its points clockwise, it would be PQR. If I do the same thing with the image, it's PRQ. Right away, that tells me this is a reflection. And the rule, your rule always starts with X comma Y arrow, and then what happened to the X and what happened to the Y? Well, what we said previously is that the X coordinate equals the X coordinate of the pre-image, so it's just X comma, and for the Y coordinate we said it was the opposite sign of, so it's negative Y. And there is our rule for this transformation. They're also asking us to find the lengths of the sides of the original triangle, the pre-image, find the lengths of the sides of the image so that we can compare those lengths and demonstrate definitively that this is a rigid motion. So I've copied and pasted the coordinates here in the upper right-hand corner of your screen so that we have them to refer back to. For PQ and P prime Q prime, however, if we look at the diagram, I'd hope that you'd notice that using the distance formula isn't necessary. Those are horizontal segments, so we can just count the spaces. PQ is 1, 2, 3, 4, 5, 6. And P prime Q prime is also 6. We've got to use the distance formula. So the length of QR is 1 minus 3 squared plus negative 4 minus negative 1 squared. So that's, inside the parentheses, I have negative 2 being squared, that's 4. In the second parentheses, I have negative 3 being squared, which is 9. So that's the square root of 13. Now let's do Q prime, R prime, same way. 1 minus 3 and 4 minus 1. And I have negative 2 squared, which is 4. 4 minus 1, which is 3 squared, which is 9. So I also have 13. Finally, the length of PR, 1 minus negative 3, negative 4 minus negative 1. So that's 4 squared is 16 plus negative 3 squared is 9. So that's square root of 25, which is actually 5. That's nice. And for finally, P prime, R prime, 1 minus negative 3 and 4 minus 1, giving me again 4 squared is 16, 3 squared is 9. That's the square root of 25, which again is 5. Since lengths of pre-image equal lengths of image, the transformation preserves length. And it wants us to do the exact same thing with angles. Well, angles, we don't have a method for calculating algebraically in this class, but we do have protractors. So let's use that. and measure angle P. I put the vertex of my protractor at P and measure angle P. It's about 40 degrees. Measure R. It's looking like 60 degrees. And then angle R is 80 degrees. So let's document that. And check it against angles P prime, Q prime, and R prime. Angle P prime is 40 degrees. Angle Q prime at 60 degrees. And angle R prime at 80 degrees. So once again, since angles of the pre-image are the same as angles of the image, the transformation preserves angle measure. In example 2, you're using coordinate notation to write a rule for a transformation that is not a rigid motion. So they're telling you that right out of the gate, that it's not going to be a rigid motion, but they do want you to go through the process of confirming that it isn't a rigid motion. And once again, example 2 has a part A in your text. It's completely worked out for you, so I didn't want to go through that problem with you. But you might want to pause the video at this time to glance part A over before you go through part B with me. So in part B, they're giving us triangle MNP and triangle M prime N prime P prime. And they're giving us the coordinates of the pre-image, the coordinates of the image, and asking us to compare them. So the x coordinates what I'd hope that you would notice is that the x-coordinate of each image is twice the x-coordinate of its pre-image. The y-coordinate of each image point, let's compare those. Again, I would hope that you would notice that it is half. So the transformation would be given by the rule x comma y becomes 2x comma 1/2 of y. And then they want us to compare the lengths of one of the segments, one of the pairs of segments, in order to demonstrate that they are not, that this is not a rigid motion. Okay, so for the length of MN, we have 4 minus -2 being squared plus 0 minus 2. So 4 plus 2 is 6. 0 minus 2 is negative 2. So I have 36 plus 4 is 40. And then I go through the same process with m prime, n prime. So 8 minus negative 4 and 0 minus 1 gives me 12 squared plus negative 1 squared, and that's the square root of 145. And since mn does not equal m prime, n prime, the transformation is not a rigid motion.